All right. Let me know if you can see my screen. I'm going to go into presentation mode. Does that work, Matvey?
Yep, we can see it.
Right. All right, so we'll get started. I'm getting my coffee just now. Thank you. Um, Thank you all for coming through. My name is Makoto Eyre. I'm a habitat distributed systems engineer at Blue Origin. What that means, what that entails, we can kind of dive into in a little bit. I just wanted to run through a handful of slides to kind of provide some context as to how I arrived at what I consider to be a pretty interesting spot. The title to this presentation is extremely cheesy, but it's reflective of I guess the theme that I try to maintain. For the most part, it's good to just kind of follow your nose, find what's curious, what makes you interested, um, and yeah, just kind of follow that along. So hopefully it's a fun ride. So to go way back, and sorry, another thing, I'm going to try to go through this quickly so that we can get to a Q&A session. I think that that's way more interesting than me just talking. This is just for some quick context. But with that said, to go way back, I was born and raised in New York, and the main thing that I kind of want to highlight here is I've always been fairly technically oriented. I did well in my math and science courses. I went to the high school for math, science, and engineering. And I wanted to be an aeronautical engineer for Boeing when I was young. But all of my friends were artists of some kind, visual or musical artists, and we would skateboard around the city, hang out on rooftops, and I think just being around that all the time and digesting the city, digesting the context in that way, really influenced the way that I thought, and forever cursed me, if you will, to be with between the technical and creative states of mind, which I don't think are mutually exclusive. I think that's a false dichotomy, but still, our society likes to draw that line. After adolescence, I went to the Rhode Island School of Design, where I earned a degree in architecture. Our studio looked like this pretty often. There were large drafting tables. We had a ton of paper around. There were cardboard models. And here we really learned how to look for patterns in the world, I suppose. So basically, the most boiled down architecture lesson you could get is if you could find A, B, C in the world, your design could do D, E, F, right? You basically just continue a pattern and you make sure that that is consistent in a design. That is essentially what your concept is, and that consistency manifests beauty in some surreal way. And so that was really interesting. I enjoyed combining that state of mind with my upbringing, so looking at the urban context, looking at New York, my home, and seeing what kind of patterns can emerge. And I found that the separation between public and private spaces is a really fascinating way of looking at cities. And if you look at cities in that way, you start to notice that the ground condition is all public and everything above is private. And as the world grows more urban and the population of the world continues to grow, that is not necessarily a sustainable motif. We either have medium density sprawl or high density with just like disproportionate amount of private spaces. So the thought here is, what if we start to provide public spaces on rooftops, connected with a series of bridges and elevators, and started to make the public domain more three-dimensional in cities. With that, graduated with my bachelor's degree in architecture, and started working in Seattle for a firm called SKB Architects. They're a high-end boutique firm, where I got to work on large-scale high-end commercial projects like this one. This is a project that we call 400 Fairview. Really interesting threshold between the public and private realm again. The ground condition essentially opened up when there was good weather and there was just a large market hall that was open to the street. We also did a lot of high-end residential and high-end retail or commercial restaurant spaces. The main thing that I really took away from my 3 years of working as a professional architect, and pretty much all of that was here at SKB, was how to detail, right? So in architecture school, I learned how to look at the world, how to find patterns, and to synthesize those patterns into forms. But manifesting those forms into actual designs can you either make it or break it through the detailing. And one thing that I'd like to emphasize here as an example of that is this half-inch reveal, right? This little shadow line that separates the kind of stone-looking soffit and this metallic ceiling. That line makes so much of a difference. And that seems like just a small detail that is overly nuanced to emphasize, but I think being able to appreciate those types of things really set me up to be able to move forward into a more challenging domain. And with that, it's like, okay, so I started practicing architecture for 3 years. I had been building up to that point. Why did I start to transition? And essentially, there was an impatience that was growing in me as I was working in architecture. And this goes back to the note that I was making before about following your nose. I think if you listen to yourself, you will know if you're in the right spot. There will be something inherently unsettling about where you are if you aren't. That's not to say jump ship quickly, right? Give things to allow things to develop, and growth can be a painful process as well, so you can mix signals there. But if you start to find yourself in a rhythm that is comfortable, but you are still not satisfied, I think that there's something to change. And I found myself feeling that while working in architecture. I just wasn't on a trajectory that would land me in a place that I would deem satisfying. Simultaneous with this impatience was SpaceX's attempts to land the Falcon 9 booster. And I kind of saw this retroactively, but the first time I saw the video of the Falcon 9 booster landing on Of Course I Still Love You, the drone ship, I don't know if you've seen that video, but the cheering that you hear in the control room, like you hear all of the engineers and the blood, sweat, and tears that went into that project. Like it was so raw, it was raw humanity, right? It was like there was something about that moment that just seemed like that is what it means to be human, or at least partially, right, for me. And so I had to be a part of that somehow. And so I took myself out of the architecture profession and put myself back in school. I initially went to the North Seattle College, which is like a regional college, to cover some prerequisites for some engineering degree. I wasn't exactly sure what. I just knew I had to start learning it. And there I participated in a rocket engineering group. And this group participated in a competition called IREC. We successfully launched an M-class solid motor rocket that had a novel ring fin design here in the back. And I can go into details as to why we did it that way, but it was just a really fun project, super interesting. And the main thing I took away from this phase of my life was just the value of being with people that you're, like, being physically present with the people that you're working with, and to fail in front of them and then succeed in front of them. Like, do that with each other. That creates such a strong camaraderie. I look back on this experience fondly, even though it was just less than a year of my life. I then moved on to the University of Washington, where I got a degree in mechanical engineering. And while there, I found a lot of interest in bioregenerative life support systems, so essentially using biological processes to support life in challenging environments, namely space. And so here I started a project that turned into a capstone, 2 capstones actually. We got mechanical engineers, mechatronics engineers, bioengineers, and chemical engineers to design a series of photobioreactors. This was our first testbed prototype that used algae to absorb carbon dioxide from atmosphere. We then tried to package it into a more appealing design for terrestrial use. During that time, I started an internship with Blue Origin, and this was really my first foot in the door. here I was a space architect intern. I wish I could show you some of the things that were produced here. This is not one of them, but it's indicative of, or it's a good representation of how Blue Origin values good design, which is something I'm thankful for. You don't find that all the time in engineering contexts. But it was a super valuable experience. And, after that experience at Blue Origin, I had about a quarter left in school. And before transitioning out of my life in academia, I had one more internship with NASA where I worked on the Gateway. And a thing to emphasize here is I purposely wanted to sample very different parts of the industry, right? Going from Blue Origin to NASA, those are very different mindsets, very different ways of working, very different paces. Ideally, I would have had the time to fold a bit of time in, with SpaceX as well, but that didn't happen. Regardless, I think the thing to take away here is internships are a tremendous opportunity to have a very short sample rate for what it's like to work in industry. You have roughly 3 to 6 months to experience at a place, and then you could do that repeatedly at a series of places. You don't have a sample rate like that after school, right? If once you get a job with an entity, you likely need to stay for at least 2 years. Otherwise, that doesn't look too great on your resume. Obviously, you could do whatever you want. Your destiny is in your hands, but really, there's just a tremendous opportunity while you're in school to just see what is best for you. And the best way to do that is to put yourself there. The other thing that I worked on while at NASA was this pressurized test chamber for isolating astronauts to simulate deep space missions. And did a little side project while there, which was a restraint and mobility aid that the user could pinch. This is such a tangent. I just wanted to throw it in, though. I found that most restraints and mobility aids tend to pinch the user. Like if you think about the thigh restraints that you might see on space station, if you don't know what I'm talking about, look up Skylab. Skylab's galley table had these thigh restraints, and apparently they were comfortable enough, but they kind of pinch the thighs, and that just seems a little claustrophobic. I think instead it would be nice if the user could modulate the amount of friction and tension that they're experiencing with the device. So this was an attempt at that. There's some flaws in the design, but it was a first attempt. And then after that, I got a full-time position with Blue Origin, and I'm here now as a Habitat Distributed Systems engineer. This started in November. I pinch myself nearly every day. There's some days that are just pure work, right? But it's a surreal place to be in. And this was a real quick run through as to how I arrived at this spot. But and I just lightly touched on a few lessons along the way, but I hope that provides some insight as to the method that I took to get here. And I continue to apply that lens. This is a place that I've been striving to arrive at for quite some time. But I don't put myself under the illusion that because I wanted to be here, that means that this is the right place for me. So far, it's been great, and it seems to be the right place, which I'm thankful for. But I think always keeping an eye out for what your subconscious is telling you as to whether or not the context actually is the proper fit for you is vital. And if at any point I pick up on a signal that says, hey, it's time to move on to something else, I'm probably going to give myself the room to jump ship sometime there as well. But I doubt that will be anytime soon. So with that, that's the end of my race of a presentation there. I really wanted to get to the Q&A because I think that again, will be far more interesting. So
we've actually got a question in the chat from Rod, who's been helping us out from Spacebit.
Great.
It's about the algae project with the bioreactor.
Yeah.
What algae did you use, and what was the production rate of it, and how many grams per liter per day?
Yeah, those are some great questions. So the type of algae that we used was Chlorella vulgaris. That is really bioregenerative systems will, the most commonly used algae are going to be Chlorella vulgaris or spirulina. Chlorella vulgaris is used because they're very robust, as in they are able to live in a wide range of pH levels and temperature. They're also small and round, so they don't get stuck in mechanical components. That said, they have thick cell walls, and they're not great to eat for that reason. So you typically need to process them in some way. So if you wanted to really close the life support loop and include the biomass produced by these bioreactors, if you wanted to include the biomass as a part of the food that the astronauts will consume, then Chlorella vulgaris may not be the way to go, which is why people use spirulina. That's way more palatable. It's more, I guess our bodies can just like digest it and eat more easily. The downside there is they're larger organisms, and they're kind of worm-like, and so the possibility for them to get caught in some part of a mechanism is a little bit higher. If you're familiar with the Melissa project done by the ESA, they use spirulina. As for the growth rates, in regards to grams per day and all that, that was really what we were trying to we were trying to find variables for controlling that as best as we could. The main inputs are going to be the amount of CO2 that's in the air, and the light intensity. But in addition to light intensity, there's going to be light color and day-night cycles. There's also a strobing effect that you could do that cycles photosynthetic creatures through their light-dark cycles a little bit faster. There wasn't like a fixed growth rate that we experienced there. So the thing that we really wanted to hone in on was essentially how to best optimize the system so that we're minimizing energy inputs while optimizing for O2 output as a proxy for the amount of CO2 that's been absorbed. So that's a bit of a non-answer there in regards to the amount of algae culture that we have. But, yeah.
So we've got another question from Sam Ross. You can read the chat. You want?
Yeah, I just now saw how to get out of share screen mode. Sam Ross. With the core space industry, is there much thought going towards long-term space habitation and architecture beyond small outpost stage? Yeah. Okay, cool. As an insider. So I'm glad that you said that. Something I should have said at the very beginning of the presentation is, although I'm wearing a Blue Origin shirt and had Blue Origin logos in my presentation and all that, and I am an employee of Blue Origin, all the things that I'm saying here are not, I'm not being a representative for Blue Origin, right? These are my personal opinions, and there are limits to what I could share in regards to what we're doing at Blue. What I can mention is our mission at Blue, the vision, is millions of people living and working in space to benefit Earth. So if that gives you an idea as to like whether or not we're targeting projects that are beyond small outposts, yeah, I think that starts to reveal a little bit of what we're trying to do. The nuance in the answer then really becomes like when, and what is the sequence, what is the staging, what comes first. And it seems like the industry as a whole is moving in the direction of, well, at the very first step, the first gate that we need to go through is reducing the cost of access to space, right? Both SpaceX and Blue Origin are looking at launch costs, but launch costs, launching things isn't the only way of getting things into space. There are mass drivers. There are these interesting like kind of slingshot mechanisms that some people have been developing. And so whatever brings that cost down per kilogram will be a key first step. And I think commercial space is mostly focusing on that. In regard, sorry, I think I'm hearing some echo. I feel like there was a second part to that question. Mars, Moon, and Mars architecture, all that kind of stuff. So, okay, yeah, the Artemis program targeting the Moon. We definitely plan on that's NASA's program for getting astronauts back to the Moon. The whole motto there is this time to stay, right? So it's more than just a temporary outpost. That's the intent, at least. And the way the industry is viewing that is it's an opportunity to start mining resources. And that's kind of like the second thing, right? So the first thing is really launch, or rather access to space, and the second is resources. And all of that will help support some kind of human presence in space, whether that's on the Moon and Mars, or if that's space stations, that's kind of up to the different entities. I think we know SpaceX's preference, and Blue Origin, I can say we prefer space stations like microgravity presence. I see some other things popping up here. Mappy.
There's also some questions that we collected earlier.
Okay.
One from Pavlicek about how did you get. Sorry?
I was just going to say, let me know which ones you'd like to answer. I'm open to whatever.
So one is by Václav Blue Origin. So your main responsibilities and what you enjoy most your work.
My main responsibilities and what I enjoy the most at work. Okay. Also, I saw that you were lagging out there. That might be my internet. I apologize if I'm cutting out. Yeah, so essentially, what does it mean to do habitat distributed systems engineering? So that there is this idea of space architecture, right? You are essentially you are molding the habitable volume in a manner that makes it most accommodating to the human psychology and physiology. Another way I like to think of it is lifestyle design, right? What are the things that humans interact with, and what does that imply about the way people will go about their life in space? That is one major component. The other component of habitat distributed systems engineer is the distributed systems component. So the underbelly, all of the utilities that are necessary to maintain the station, the resources that exist up there. If you think about any building that you inhabit here, we've developed a system that is very streamlined. You have these finished walls so that you have a nice habitable volume, and behind those walls are going to be all of your utilities. You've got your plumbing, your electrical conduit, your HVAC, your air and ducting. That's probably going to be in the ceiling, but that's all behind the walls. You never see it except for a few key interfaces: the outlets, the faucet, the vent. That system doesn't really exist for space stations yet. If you look at the International Space Station, a colleague of mine once described it as living inside of a VCR, which I think is a pretty apt description. Like it's just you're inside of a machine. There are cables all over the place. The guts of it are spilling out, and that's just because it's humanity's third big attempt at creating a space station. We need to iterate more. We need to just keep trying things out. And so the role that I have is we have a space architect in-house, like a full-time space architect. We also have a bunch of super talented engineers, and I basically sit at the middle. My role is to find the synergistic relationship between those two places.
There's some more questions in the chat as well. One from Piotr. What impact on future space exploration may increasing amount of space junk have? And what are the current plans in dealing with it? So Kessler syndrome.
Yeah. It's a big threat, and no one really has an answer to it at the moment. Not serious ones, at least. There are some interesting concepts out there for capturing and deorbiting or capturing and mining some space debris, but it's such a big problem that likely isn't a commercially viable thing. Commercial space is going to be a pretty big challenge. It's an exciting pie to have to be a part of, and once some of these gates that I mentioned begin to unlock, then it'll become more viable. Business cases will close, but it's a challenge. And so, like, mining space debris, I think is a bit of a difficult one. The most realistic answer that I've heard so far for deorbiting space debris is to send up a pressure vessel full of a gas, say CO2. You get into an orbit that you want your big space station to be in, and you just release a bunch of that gas at high velocity. And that gas will act as a medium to impart some drag on the space debris in that orbit. And then you would slowly deorbit all that stuff. And the gas would sublime over time. So you wouldn't need to worry about an excess of ice particles just being in orbit either. But that's just, a concept. I don't think anyone has detailed anything out for that.
We're kind of running out of time, but I think there's one last question from Rod about what are the most important things that you're considering while designing lunar habitats, particularly habitats in lava tubes? I think this is in the context of basically exploring lava tubes, which collaboration is exciting.
Right. Lava tubes are an interesting one. It's going to be fantastic for radiation protection. So most important things to consider. To call out any particular thing is difficult. It needs to be. This is a dry answer, but it needs to be cost effective. There are so many concepts out there that could technically work, but they're just not commercially viable. Read The High Frontier. That has nothing to do with lunar habitats. It's actually lunar resource extraction to produce habitats in microgravity environments. But it's this pie in the sky idea that was developed in the 70s that basically sets up these O'Neill cylinders, these space stations that would rotate to create artificial gravity. And the book demonstrates that it's technically feasible, even from the 70s, right? And because it was technically feasible, the author just started going down this whole train of like this timeline of how we're going to have hundreds of thousands of people living in space by 2000. It was like this insanely optimistic timeline, and it basically came down to just not having a business case that could close. So that's one component. I think you might want more of the technical answers, and I would say radiation. Consider things about like MMOD shielding. It's not as big of a deal as on orbit. MMOD is micrometeorites and orbital debris. So things are going to be impacting the lunar context. You're going to need to shield the habitat from that. Now, with all of this shielding, you still need to provide something that enables people to look outside, right? It needs to be a space for people to inhabit happily. I know we're out of time here, so I'm trying to rush this answer here, but
it's okay. You have some time. The next people aren't ready yet, so
okay, great. But I would say that is yet another thing that you really want to focus on. You need to have windows. Need to have a way of going outside EVA, and I guess consider the human factors in ergonomics. Right, you're experiencing 1/6 gravity, or 1/6 of Earth's gravity. Stairs are going to be different. Shelves are going to be different. What it means to go to bed is like it just all changes. The assumptions that we have about what it means to live inside of a thing changes every time we go to a different context, be it microgravity 1/6 G for Moon or Mars gravity. Like that's why this domain is so interesting. There's just so many problems to solve. Everything needs to be questioned.
We have another question from John Yao. Do you think that human occupation of space in the near future is probable? Or do you think it will be more robotic in nature?
Yeah. It's possible. I think what I got caught up on earlier applies here too. It's completely technically feasible. I don't know about deep space, but low Earth orbit, absolutely. We can get people to live there, and I think space tourism will be a thing. Whether like commercial space, if we're going, whether or not there's going to be like a WeWork in low Earth orbit is a bit of a question mark. It's expensive to have people up there, and with automation being making the strides that it has in the past couple of decades, it seems like robotic maintenance of stations is the most commercially feasible option, but that's not as fun, and I think a lot of people feel that way. So yeah, you're saying in my lifetime whether or not that's going to happen, and I would say yes. I don't know how many people can go, but way more than 6.
There are a few more questions that were sent earlier. One from Daniel Ringrose about 3D printing and use in space. So what is the best 3D printing to use in space to build your designs, for example?
That's still being explored, man. You know, it's if I had the answer to that, I would probably have my own company. That's yeah, that's a difficult one.
And there's one question about your career. What's the most vital thing you did that allowed you to get to where you are? This is from Philip.
The most vital thing?
And what do you think was the most vital thing you did during your career that allowed you to get into the space sector?
Networking. I mean, you know, as someone that is, I think most of us here are naturally curious people, and so we don't have to try to explore the things that make us curious, which is why I say networking. I can spend all day making a design, reading papers, and just learning and making, but that isn't necessarily, and even if I put that online, that's not necessarily going to get me anywhere. What got me this job really was the director of the advanced development program. His name is Brent Sherwood, and he has a background in architecture but worked in space for a long period of time. I happened to come across his email. I knew that he was in Seattle. I was in Seattle. Shot him a couple of emails, rather persistently, you know, requesting some time to chat, and we met up for some drinks, and I think we you know, hit it off. So being able to meet the right people at the right time is a major one. If you just practice by going to conferences and speak to people, I think that is more than sufficient. The industry is small enough that you will quickly start to find the same names coming up, and you'll know what circles you need to be in.
Great. If anyone else has any questions, you can ask in person as well on the mic. So the BAE systems are a bit delayed currently, so it's your stage.
Okay, cool. Yeah, I mean, I've got plenty of time, so open to whatever.
Thank you so much for talking to us, Makoto. It was very, very, very interesting, and it gives a lot of us young professionals much scope. We really, really hope to have similar epiphanies as you, and I think you put a lot of things in very nice words. A lot of us question the fields we're getting into sometimes, and as young people, question the decisions we make. But it's very reassuring to know that it's gotten you to a happy place that you are. From my side, I think we're good with questions. Let's give everyone a 1 to 2 minute break maybe before BAE hops on at 40, if that's okay with everyone.
Sure. Yep. So BAE Systems will start presenting at 4:40.